So, welcome to another presentation on network analysis subject. We are seeing different important topics from this particular network analysis subject. So far, we have covered or we have seen the nodal analysis concept as well as the mesh analysis concept for the given electrical circuits. In today's presentation, I would like to cover the network theorems, which is a very important topic as far as our network analysis subject is concerned. We have various network theorems which are to be used to analyze the given electrical network or electrical circuit. There are various theorems are there. So in each of our subsequent presentations, we will cover each theorem with their definition and then some of the examples based on those theorems we will cover in our subsequent presentations. In today's presentation, I would like to explain you about the superposition theorem. Superposition theorem states that as per this superposition theorem, as I defined here, the voltage across or the current through an element in a linear circuit is the algebraic sum of the voltages or current through that particular element due to each individual independent sources acting alone, right? This is the basic definition or the basic uh, okay definition of the superposition theorem. Very easy definition actually. So the meaning of this particular definition is that for any given linear circuit, in fact, the superposition theorem is only applicable for the linear circuits. Linear circuits are nothing but where the circuit has linear elements. What are the linear elements? So those are like resistors, capacitors, and inductors or LC. Wherever these components are present, there only the superposition theorem can be applied, and the superposition theorem is not applicable for the non-linear circuits. What are the non-linear circuits? Non-linear circuits are the circuits where the non-linear components are used in that particular circuit. What are the non-linear components? Non-linear are nothing but like the diode and the transistor, etc. So wherever the diode and transistors are given in the circuit, for that type of circuits, the superposition theorem is not at all applicable. It is only applicable for the linear circuits where the linear elements like resistors, capacitors, inductors are used. That is very fundamental point to note down, right? So what is the definition says? So for any given circuit where we have different resistors and then or capacitors or resistors, inductors, whatever it is, so assume that in the given that particular circuit, if we have different independent sources, so what are the independent sources are nothing but voltage source and then current sources. They will not depend on any other element of the circuit. Okay, those are called independent. So suppose we have different independent sources. Independent sources can be voltage source as well as current sources. Okay, so you may have different voltage source or current sources. Okay, so we let us consider any one particular element, maybe one resistor. If across that particular resistor it is asked to find out the either voltage across that element or current flowing through that element, what we have to do, that particular parameter, whatever is asked in the problem, we should calculate with respect to both the or whatever the sources, independent sources available within the circuit. At a time we have to consider one particular source where the rest of the sources can be switched off, can be put off. So if the three sources are given, so we have to consider the first source and then remaining two will be removed. And with respect to the first source, we have to find out the given, whatever the asked, maybe voltage across that element or current across through that current a resistor, like that. And that is the first step. And secondly, we have to consider the second one, where the first and third will be switched off, and we have to find out the element which is asked. And similarly, due to the third source, where the first and second will be removed, and with respect to the third, we have to find out whatever the element is asked. Then we have to sum the sum the voltages or the currents due to all these individual three, and we have to sum up. Then that will be the answer for that given question. That is very simple. That easily can be understood with the small example which I am going to solve now. Right? Remember that the voltage across or the current through the element in a linear circuit, in a given linear circuit, is the algebraic sum. That is very important. The algebraic sum of the voltages or currents with respect to that particular element due to each individual independent sources acting alone. What is the meaning of it? It is very simple. Let us consider a small example so that we can understand the superposition theorem very easily, right? So let us take a simple example to understand the concept of this problem. So for this, there is a small simple example is there, where I have a simple circuit. I have a voltage source in this, I have a resistor, right? And then I have another resistor is given like this, and I have a current source is given like this, this is the current source, right? It is 8 ohm resistor given in the problem, and it is 6 volt voltage source, and then it is 3 amperes current source, and it is the 4 ohm resistor. This is the simple circuit is given. My question is, what is the voltage across 4 ohm resistor? What is the voltage across 4 ohm resistor? Find out. That is my question. Find voltage V. What is V? Across 4 ohm resistor. Across 4 ohm resistor using superposition theorem. SP I can write. Superposition theorem. This is a simple problem. If you can observe this problem, this is a simple circuit where we have two resistors, 8 ohm and then 4 ohm, and it has two sources. Let us see, 6 volt current, 6 volt source, voltage source. It is a voltage source and its value is 6 volts. It is the current source, its magnitude or its value is 3 amperes, right? There are two, these are called independent sources. Independent, they are not dependent on any other element. They are independent, they are separate. They will not depend on any other thing. This is the voltage source, this is the current source. Two sources we have in this, right? Then what to do, how to find out the voltage? So now I am explaining the solution part. Very easy. So the solution part is very easy. Okay, solution, what to do? We are going to find out the V, right? My objective is to find out the voltage V. So how this voltage will be calculated? What is the value of V? Okay, so my V is nothing but, actually my V is nothing but the voltage V must be, how many sources are there? There are two sources. One is voltage source, second is the current source. So means that what, with respect to the voltage source, I have to find out the voltage V, that you can call it as V1. And similarly, with respect to the current source also, I have to find out what is the voltage, this V. Okay, that is V2, right? This is what. So if you find out V1 and then V2, if you sum up both V1 and V2, then whatever the value comes V, that is the voltage value across 4 ohm resistor. That is your answer, right? So V is equal to V1 plus V2. Let us consider V1 is the voltage. V1 is the voltage across this 4 ohm resistor with respect to 6 volt voltage source. So what to do, So for finding out this V1 value, that is nothing but voltage with respect to 6 volts. V1 with respect to 6 volts. V2 with respect to 3 ampere current source. Better to note down like this. So while finding the V1, that is with respect to 6 volt voltage source, what to do for 3 ampere? 3 ampere must be open circuited, that must be removed actually. At a time we have to consider one source only, that is the important point to note down. Okay, while considering one particular source, the other source must be switched off, right? Must be removed otherwise. So for finding the V1 means that for by considering the 6 volts voltage source, I have to remove this 3 ampere. How I have to remove? Simply you have to open circuit it. Means that you have to remove this. If you open circuit it, then that is nothing but simply if you open, then your circuit will be like this. It is open circuit. Okay, but so how you remove the 3 ampere? Simply you open circuit it, then that means that 3 ampere current source will be removed from here. Then this is what the circuit actually. Now what is the voltage? This is nothing but you can call it as V1. Therefore V1 is equal to, according to our voltage divider formula, V1 is equal to input voltage 6 into, so voltage across, V1 is the voltage across 4 ohm, therefore 4 by 4 plus 8. Clear? 4 plus 8. This is according to the voltage division. Therefore, it is 6 into 4 by 8 plus 4, 12. Therefore, 4 ones are, 4 threes are, 3 ones are, 3 twos are. Therefore, it is 2 volt. Therefore, what is your V1? V1 is equal to 2 volts. Right? V1 is equal to, your V1 is equal to 2 volt. Right? That is with respect to your 6 volts current voltage source. Now, that is step 1 actually. Now coming to the step 2. What is the step 2? Step 2 is nothing but I have to consider this 3 ampere current where the 6 volts voltage source must be removed. How the voltage source will be removed? So means that if the voltage source is there, then I have to make short it. The voltage source must be shorted. The voltage source must be shorted actually. If the current source are there, that will be opened, whereas the voltage source is there, that must be shorted, right? Then so if I short this voltage source, means that I am considering the current source. It is 2 volts. Remember, V1 is equal to 2 volts, right? Now I have to connect this 3 ampere current source here like this. It is 3 ampere current source. Now with respect, okay, I am connecting this 3 ampere current source here, right? Then so the voltage source must be shorted. That means that we are switching off it by shorting it, right? Then this is the current, 3 ampere current, and how to find out the voltage here? If the current is there, then it is easy to find out the current flowing through 4 ohm resistor I. It is again current division formula we can use. So to find out the current flowing through this 4 ohm resistor, then I is equal to, by using the current division, what is that? Input current 3 ampere into, so 8 by, here 8 by we have to take, this resistor we have to consider 8 by total resistor, 8 plus 4, very simple. So further 3 into 8 by 8 plus 4, how much? Again it is 12. So how much it is? It is 4 2s are, 4 3s are, right? 3 both are cancelled. It is 2 amperes. So your current I is equal to 2 amperes. So I flowing through 4 ohm resistor is equal to 2 ampere. Then what is the, now you can call this V as V2 actually. With respect to 3 ampere, I am calling this voltage as V2. Therefore, V2 is equal to how much? V2 is nothing but 4 into I. Resistor into current, 4 into I. So 4 into, it is 2. It is 4 into 2, how much? 8 volts. 8. Therefore, your V2 is equal to 8 volts. Now, so what is your total voltage? You know V1 value, you know V2 value. Therefore, your V is equal to V1 plus V2. V1 is 2 volts, V2 is equal to 8 volts, total is equal to 10 volts. Therefore, this is the answer. This is the answer. This is what the final required answer. This is how we can simplify the given network by using the superposition theorem. Yes, in the given problem we have two sources. So at a time we have to consider one source only, and the remaining source we have to put off condition. And we have to find out with respect to the one source, find out the voltage asked as per the problem. And the second step, then switch off the first one, consider the second one, find out the voltage, and now you have to add. So this is what algebraic sum. This is what the algebraic sum of the voltages. So I hope you understood very well, and we will see some more examples in our subsequent presentations. Thank you very much.